example 4 on page 253. It says a salesperson receives a large bonus for having the best sales record of the year. If she wants to have $25,000 in 5 years for the down payment on a house, how much must she put aside at 7.5 compounded quarterly? No one is getting that. No one. This is like make-believe world. This is fun. We're using numbers. All right.
Wow. Good job.
Yep. So says my future value is equal to 25,000. We are looking for present value. The rate again was what, Derek?
7.5.
7.5. The time is what? How many years?
5 years.
And compounded quarterly, right? So n,
yes.
yeah. So n will be 4. Perfect. So if we set this up here, we'll see we have FV. Now we can do this one of two ways. So you can keep this for your notes if you like. So before I've even done anything, you can do one of two things. We can just plug in numbers and then divide off, or we can just divide the letters now and then just plug in the numbers, so you don't have to do any additional work. Sure.
Yes.
So I'm looking for PV. So in this case, if I just divide off the 1 plus r to the n Tn power and put it over here. Oops, not TH, that's my initials. We're left with the present value is equal to the future value divided by 1 plus r n to the Tn. All I did was, if you assume, think of this as like one number. This is like x, and this is 2. So think of this as like 2x. In order to get it to be x by itself, we just have to divide by 2. And when I do that, there you go. So now we'll go and plug in all the numbers. And you put a box around this, you can do in your notes, you can come back to everything like that. Yep. All right. So for this, you get future value is 25,000. Alright, over 1 plus r is 0.075 divided by 4 to the 5 times 4 power. Yeah, let's do the new, just think of it like this. Yeah, start with the denominator first. So the only thing that we're really doing different is just the sequence. I'm going to move over here where I got a little bit more room. So 25,000 over, okay, so what's inside the parentheses? What do you guys get for? So 0.075 divided by 4 plus 1.
1.01875.
What'd you get there? Just want to verify.
1.01875.
Okay, yep, you guys got the same thing. So say that one number, say it to 1.01875.
0.1875.
Okay. To the 5 times 4 power, which is 20. All right. So then 1.018275 to the 20 power is what?
1.45 is close enough.
Go 2 more decimal places.
It's 1.4499.
Oh, okay, that's why you, okay. Okay, I see why you did that. No big deal. And when you divide that now, 25,000 by this, what do you get? Or how about this? Let me do the math and then I'll ask you. I got 17,242. 56 cents. Yep, that's where, yep, she needs tomorrow, is what I need. In Venezuela. Alright,
So she has 17 grand, and it's gonna take her 5 years to get to 25?
yeah. At that interest rate compounded quarterly. But no one's offering those rates. I think you might be lucky to get 2.5% compounded monthly.
Yeah, I mean, judging by the pay I get, it's probably 2,000 a year.
Yeah, it's,
I
dude,
mean,
interest rates are horrible when it comes to like saving money. Yeah.
You're getting off interest rates because of that.
Yeah, exactly. Alright. Okay, do me a favor, go through the examples real quick, right up there up front. Okay, any questions on how to do that? That's pretty straightforward. So that's the equation if you need a present value and you have the future value. Okay, so just start that, make sure you keep that in your notes as well, etc. Go through the examples real quick. Is there one where it tells you to find t? It gives you everything except for t. How long will it take?
The examples? No. The next example, the P is the unknown, just like this one.
Okay. Any other?
Let's go past these and went down here.
Probably not. Yeah, they're all just that. Okay, good. I thought there was. Okay, forget it then. You guys want to do one more, or are you guys comfortable with this? It's pretty straightforward. Well, one more, Kev, or?
Yeah, I'm on me.
Okay. We'll skip straight over to the example of the exercises.
Repetition training.
Yeah. How about, ooh, that's a good one. Number 21. $7,000 loan. So future value equals present value times 1 plus R over N to the Tn. Okay, so it says $7,000 loan. 4 years. There we go. At 5.5. And compounded continuously.
Yes.
Continuously, meaning daily?
I believe. Snoo,
365 for continuously?
Oh, that's right, I haven't done that one. My fault. Sorry, I knew we forgot something. Sorry. Okay. I screwed up, my fault. On page 252, there's a special equation.
Or it could be,
Com-
oh, sorry.
Oh, no, go ahead.
I mean, it could be, that's example 3 here.
Yes, A firm. Yep, that's what I just right here, the equation right up here. Yep. On page 252 is the equation. Future value is equal to the present value times E, which we talked about last night, to the power
5
RT.
times T.
So in your notes, write continuously compounded interest right here. And guess what? Everything's still kind of the same. Just plugging in numbers. Yeah, because all of them are P now. Anything else like that? That's good. Okay. All right. So for this, Kev, we just plug in. Then we're looking for future value. So that's equal to P. Yep.
7,000.
Yep.
Times that
E.
E
Yep. To the.
to the rate 0.55? 0.05.
Yep. 0.055.
Times 44.
4. Yep. All right. Okay. First, we'll do the exponent. 0.055 times 4 is
0.22.
0.22. Okay. Did I show you the E button on your calculator?
Yes.
Okay. So what you will do for the next one, you'll do. Oops, my fault. For the E this, you'll just do the, make sure I'm right.
Or the
you'll do the 0.22 and then hit the EX button. So you'll do 0.22, hit the EX button.
Shit, 1.246, yada, yada, yada.
1.24.
4607.
Okay, perfect. All right, take that times 7,000.
8,722.54 rounded up.
Yeah.
And this was for the future value?
Yep.
This right here, okay, now, I guess,
This again is if it's compounded continuously.
but how much time, well, that's over 4 years. So
Yeah.
meaning, what do you mean continuously?
Less frequently may see the future value of interest compounded continuously. Imagine that instead of daily, we had the compounding period every hour or every minute or every second or every part of the second. We would be approaching continuously, so it's just continuously.
Yeah.
So if you stop and think about that, 4 years on 7,000, it made $1,700 at 5% interest. Go back to that one, 5 years, is that one 5 years? That's 4, so that was 5 over there, it's 7, at 25,000.
Yeah, because
It's the future, so that's 8,000, wait a minute, this made 8,000 right here.
Yeah.
Shows you how much more, it made 8,000 so much quicker. Because remember, this can, every second, just imagine like counts on like,
Okay. Fuck interest rates.
so I'll give this to you as well. So if we want to find the present value for this would be future value divided by e to the power RT. We just take this portion right here that I put in parentheses, divide off, and that'll give me my present value.
And that's for continuous.
Continuous, yep. I think you're starting to understand this.
A little bit, yeah. I am very interested in interest rates at the, as anybody, should be.
Yes.
Well, the thing is, I wanna be able to discuss it with my son, especially revolving interest.
Well, he's getting to that point where he's asking those questions now, so that's good.
That's about common.
That's right. Alright. Alright, any questions on this? Anything from you, Derek? Okay, cool. Alright. Well, we'll do it at the end of the night, we'll go over a few more examples, Kev, if you want more. That's cool. Alright, so that's 7-2. 7-2. 6-2. Thank you. Alright. 6-3 now, we're gonna switch gears and talk about annuities. Alright, annuities. Alright. 6-3, annuities. Often we do not have enough money to meet the future financial goal all at one time. An annuity is a fixed sum paid over equal periods per year over some number of years at a set interest rate. A very relevant example to most people is their retirement account. For instance, somebody saving for retirement put aside $400 per month for 30 years. If the interest and payment schedule stay the same, we are talking about an annuity. Another thing you will see annuities for is two things. Number one, usually if you get into an automobile accident, they will pay you an annuity. It's kind of think of it like this, instead of doing all the saving and everything, they've given you the lump sum, and now they're paying it out. Now it's the paying out portion. We're gonna calculate how much of that lump do you need, yeah. And then the other one we'll talk about, kind of somewhat like the cousin to an annuity, would be like getting your, winning the lotto. You can either take a lump sum up front and get the per month, everything, it's a cousin related to the annuity. But an annuity in this case is going to be equal to future value is equal to the payment, PMT, times quantity, 1 plus R over N to the NT power. so far this is looking the same. Minus 1, and that's all over r divided by n. Okay? It looks complicated, but when you start stripping the math away, it's really not that bad.
Says the math.
That's true. PMT is your payment, how much you're paying in dollars. R is again your rate. N is going to be your compounding period, I believe. Number of payments, which is the same as the number of compounding per year. T is time in years. Payment, RNT, yep, and then future value. Okay. All right. Let's look at one of the examples here. Number 1 says, example 1 on page 261 says, if 400 is put aside every month at 5% interest compounded monthly for 30 years, what is the accumulated value? How much of the accumulated value is interest? Okay. All right. So starting right now, okay, if Derek puts aside 400, assuming you can get this interest rate, which you never will. All right. Okay, so right now, assume that you can get, if you put aside $400 a month, okay, at how much interest rate did it say? 5% or 5.5%?
Yeah, 5%.
5%. Okay, compounded
Monthly
so that would be N is 12
for 30 years.
for 30 years. All right, let's run and do the numbers. Okay. All right, so up first, future value is equal to 400 times 1 plus R. R in this case is 0.05. 5% turned into a decimal.
Over,
12
yeah, 12.
to the 12 times 30 power minus 1 all over what, Derek? What's remaining there?
0.05 over 12.
Okay. So step 1, Kev, when you get like these problems like this where the variables are like, oh God, my eyes are bleeding. Just simply plug in the numbers. Just walk through slowly and plug them in. You're right, like when I was in your age, she's like, oh God, this is oof. And I just learned, we'll slow down, just plug in the numbers. And then you can figure out the math second. And again, we're just going to take it piecemeal. Okay, so up first, we'll work on the numerator. We'll work on both at the same time. I'll show you what we'll be doing. Okay, so up first, we just take 400 times, what do you guys get in the parentheses first? We'll do what's in the parentheses and the power. 0.05 divided by 12 plus 1. I got 1.004167.
Yeah.
Okay. And that is all to the 360 power. 12 times 30. I put an extra parentheses here because we still have, I forgot to put that right there. All right, now I look at the denominator, I got 0.05 divided by 12.
That's at 1.004167.
Yep. Okay. we'll go back and we will do what is in the big parentheses. Okay, so we have 400. Okay, 1.004167 to the 360 power. I got, and you guys tell me if I'm right or wrong. I got 4.46827.
What'd you say then you got?
Oh god, I got it wrong. I think I got it wrong. 1.004167. And then I hit the XY button, take it to the 360. I got 4.46827.
Yes, that's true.
Okay, and if I subtract 1 from that, I got 3.46828 around it. And that's all divided by 0.004167. Now, if you finish out the rest of that, 400 times the 3.46828, so the numerator, and then divide by the denominator, you should get, and you guys will tell me if I'm right or wrong, sweet Jesus. I got, the end of the 30 years, it'll be worth $332,928
Yes.
and some cents.
And they're supposed to live off of that.
Yeah, it'll be off a little bit because we all use different decimal
Yeah.
numbers. Yep. Well, well, that's how much your lump. So that's a great question. So let's assume you live for 10 years. It's 30 grand a year.
Fuck that.
Yep. All right, so it had a part 2 on that. Part B, it says, how much of the accumulated value is interest? Okay. So then it says, the next question is, how much of the money came from interest? To get the interest, find out how much of the money came from the deposits and subtract it from the end value of the annuity. Okay? So deposits. Okay? In this case, the deposits was equal to $400 a month. Oops, not 400 months. So 400 per month. All right, times, in this case, how many years do they go? 30 times 30. But then how many months are in a year?
12.
Times 12. Okay, so when you get done, calculator, where are you? 400 times 30 times 12. I got 144,000
Got the same.
as the deposits. This is just the deposits. How much money did you spend? Okay, so now the interest, we would just take this value right here, 332,928, subtract 144,000. And again, this is the deposits. And when you do that, it is a lot of money. I got 100, around 188,928.
You got the same.
That's a lot of interest. All right.
So what is the difference between this annuity, this savings essentially, and the stock market?
Stock market's so different, so different. So what you're thinking of is more in terms of,
'Cause that's what I do, I invest in a Roth and a traditional,
oh, okay, that's fair.
as opposed to something.
So something like this is literally just a simple savings account. So and then it's just gonna be compounded. So again, 400. So it's gonna do two things. It's gonna be compounded. This one, compounded monthly. So month one, I put $400 in, get my interest. It's gonna be something super small, like maybe $3, not even that. So the next month it'll be 403 plus 400. I got $803. Another $3. Keep adding. So that's all this is.
Okay.
Stock market is in those like your IRAs, Roth IRAs. What it is, think of it as like a total value. So it is stocks, maybe some metals, rare metals, maybe bonds. Bonds are more like simple loans. That's all it is a loan. So when you go out and buy a $100 Federal Reserve note, bond, a treasury bond, sorry. You're actually you pay how much for that bond, actually. Depends on how long you're going, but usually half the value of the bond. So if it's, I give you $50, in 10 years it's gonna be worth $100. That is the future and present. So if you wanna give a good example to your son, I would use that. Hey, son, we're getting a simple loan here. I'm gonna loan the government $50, and in 10 years they're gonna pay me 100. Or how much ever it is, 15 years or whatever. I can't remember.
You got a couple of those. Yeah, okay.
Okay. Stock market is, so a great example, your Roth IRA and all that other stuff is based off of, if they sold everything today, what would it go for?
Okay.
Yep.
Not so much interest rate, it's just a value.
It's all values, yep. So you'll have that value, then you'll have those loans, you'll have some bonds in there because you want everything to be diversified. So if you sold the bonds, or sorry, if there's a way to claim the bonds, I think, yeah, you can claim them early. You might just get
A fee or a penalty, yeah.
Yep.
I don't, First Command does all of mine.
That's okay.
So, I've been with them for 15 years. Yeah. I don't know how it all works, I just know I have an allotment going to Fidelity.
Raj. Okay. Raj. Okay.
Which I probably should have a little more.
So yeah, with the annuity problems, that's all they really want you to do is calculate what is that future value, and then they'll ask you what is interest that you're making off of it. Or it'll ask you what is the present value, or what is the payment. So in this case, like, yeah, it'll ask you future value, another future value. Do you guys want to run to another future value problem, or what would you guys, or do you want to skip down to the payment one?
See the payment.
Okay, so the payment one is, they've resolved the equation so that it's payment equal, so wants to know, in the future, I want $1 million, how much do I have to put in at this interest rate to get that $1 million when I stop paying?
So it's payment equals future value
And then
times
flip it. So future value times RN over,
that conglomerate.
exactly right, genau. Yep. So I'll show you what that looks like, give me 1 second.
There, yeah, I see. Payment equals future value times RN over 1 plus RN.
Yep.
People actually use this shit every day.
Financiers. So in this case, it's, yeah. Notice it's the exact same thing. Payment. There's really nothing with the equation that's different, right? It's just flip. Future value times R over N. Down here in the denominator, 1 plus Rn to the NT minus 1. And there you go. So that's the only thing that's different, like I said, is they take the original equation and they just solve for payment. And by doing that, you flip it and then move it to the other side. Because remember, if you divide a fraction, you have to do what? Multiply by the reciprocal. Okay? So we'll look at one of the examples for these. Example 3 says, when studying compound interest, we saw that a 25-year-old would have to put aside a bit over $200,000 all at once for 40 years at 3.25 interest rate to reach the retirement goal of $750 to retire comfortably. Well, that is an amazing amount of interest. Unfortunately, many of us do not have that kind of money on hand. How much does the 25-year-old need to put aside each month to have $750 in 40 years at 325 compounded monthly? Okay, so it's asking what is the payment. So in this case, it says what is the payment? Alright, future value is, what is it asking me to have?
750.
Yep. 750,000. Okay, times, what was our interest rate?
0.0325.
325 interest, right? Okay,
Sorry.
no worries. 325 divided by,
12.
okay, compounded monthly. And that's all divided by 1 plus 0.0325 divided by 12 to the n, which is 12 times t
40.
times 40 minus 1. Okay. Let's see, we'll do the numerator first. This right here? No.
Well, yeah.
Or the entire numerator?
Well, the 0.0325 divided by 12 plus 1. Then I.
Oh, you're down here. Okay, so you're
Yeah.
doing the top. Okay, yeah, let's do
Oh,
that.
I'm
first.
sorry.
No, that's fair, that's fair. No. Okay. So what's in the parentheses right here?
It's 1.0027
Okay.
times.
To the what power?
It's gonna be 480.
480 minus 1. Okay, so that's the denominator. And the numerator, so 750,000 times, we can do this first, 0.0325 divided by 12, and then multiply it by 750,000. Oops. I got 2,031.25. So just take this, divide by that.
I keep working on the wrong
Oh.
one.
You're like, Travis, I'm in the denominator, where are you? I'm in the numerator! Jump now, jump! But there are wins!
So times 75. 203, yeah.
Okay, perfect. Alright, so now we'll go clean up the denominator. So the numerator again is 2031.25 divided by, okay, so 1.0027 to the 480 power. Minus 1.
2.64827.
Yeah, that's what I got too. Alright, and if you finish that out right there, what did you guys get?
767.0101.
Yeah, that's the neighborhood right there. About $767 a month
For 40 years?
for 40 years.
It'd be hard to do that in the beginning.
That would be. Holy hell.
I know you're all fixed.
I know.
Still, I think I started out with $50.
Alright. Any questions on those two on the board? We're in the same family problems. Yeah. To be honest, it's just manipulating the equation, if you understand that part. If you're doing the next level, the next level of algebra class, you'd have to like solve for R, solve for T. That's a little complicated. We're not gonna do that. Alright. Any questions on annuities? Alright. Let's take a break. Get the stretch. I'm gonna go to the bathroom real quick. We'll come back and we'll push through, 6-4, and that'll be it for the night.